Okay, example 4, last example in 1.1 for Math 20-1. And it's a good kind of real-world application of what an arithmetic sequence might look like. My furnace broke reasonably, so this is near and dear to me. A wants us to generate the possible charges, excluding parts. We're not going to include that for the first 4 hours of time. Now, it's ridiculous to include it, but I do want to at least make mention of what would happen at 0 hours. Again, most tradesmen and most people are reasonable that if they came out to your house and they found out your furnace was actually broken, they're not going to charge you that call out fee. That's just ridiculous. So even though I'm going to put 0 hours on here, I think it's important to recognize that this is not going to become a part of our sequence. It's just important to consider that if he doesn't do any work, we're on the hook for that $65 for the house call. Now, I want n in my arithmetic sequence to be equal to the number of hours that he worked. But n has to be a natural number, so I'm going to omit that. But it's really important that it's $65 if he doesn't work, or if they don't work. If they work for an hour, it's 65 plus 42, so we get to 107. Now, we're not going to keep getting charged that $65 because he's at our house now. So we're just going to keep on getting $42 or keep getting charged 42 an hour. $42 per hour for every hour that she works. So when we talk about what that or how that relates to the question, that hourly charge is the common difference. Because when I'm working on the furnace for 1 hour, I get charged 107. When they're working on the furnace for 2 hours, I get charged 149. And all I'm doing here is I'm increasing the amount that I'm getting charged by 42. So to go from 2 hours to 3 hours, I'm on the hook for another $42. So that's $191. From 3 hours to 4 hours, it goes up by 42 again. So it is $233, which gets real big real quick. Now for B, I fully appreciate that you could just keep, typing in plus 42 on your calculator until you get to 10 hours of work. But the point of this is not to brute force the solution. It's to use our formulas and arithmetic sequences to solve this without actually having to hit plus 42 10 times, or I guess 9 times if you knew what the first hour was. So what we're going to do instead is we're going to make our general term. So I don't know what Tn is yet. I'm going to write that formula. We know that Tn is equal to the first term plus n minus 1 times the common difference. For this particular question, term 1 is 107. We don't know n, sorry, that's D, should be 42. So my general term is going to be the 107, which is term 1, plus n minus 1 times 42. Well, that means that Tn is equal to 107 plus 42n minus 42. And I get that the general term here is equal to 65 plus 42n. And I want to hammer home that I like simplifying this because sometimes it does give us a bit of a better meaning. Tn being 65 plus 42n means that it's $65 no matter what. And then it's 42 times the number of hours that she worked plus that 65. And that's an important consideration because that's really exactly what's happening here is that this 65 we get charged regardless, and then they charge us an additional $42 per hour. So what the question asks is what happens after 10 hours of work? Well, we identified that 10 hours, the n was 10. So now my general term becomes the 10th term because I'm putting n equals 10 in, and the 10th term is 65 plus 42 times 10. So term 10 is 65 plus 420, which means that term 10 is going to be $485. And I know that seems like a really large number, but if you need somebody to work on your furnace for 10 hours, something pretty serious went wrong, and that's probably going to be a pretty reasonable rate, honestly. Okay, that's 1.1, the intro to arithmetic sequences. I'll put that assignment up. Make sure if you are having any trouble, you do email because I can help you outside of school hours as well.